Okay guys, so in the first video we got to hear where we calculated the mean and standard deviation of the residuals. So what we're going to do now, still with this same data set, just moving on, we're going to sketch a scatter plot of the residuals over high school GPA. Sorry about that, I copied and pasted these questions from another one. So what I'm going to do is in my calculator, I have everything already in here and stored. So if I go to my lists, remember L1 is my high school GPA. L2 is the actual scores of these students. L3 is the predicted scores. And L4 is the residuals. So when it says to make a scatter plot of the residuals over GPA, that means for your X variable, you are going to use GPA. For your Y variable, you are going to use the residuals. So make sure you remember where they're stored. GPA is in L1, residuals is in L4. So to get a scatter plot, we're going to second Y equals. You want to make sure that you have a plot turned on and that you have a scatter plot. We want the X to be GPA, which is L1, but now we want the Y's to be our residuals, so we're going to change that to L4. Okay. I'm going to make sure I have this cleared out. I'm going to go to Zoom 9, and I've got a scatter plot that looks like this. So I'm just gonna, let's see, I'm gonna do my best here. And this is literally just a rough sketch, guys. So let's see, now I've got something like this. Okay. So what does this mean? And what is the whole reason for doing this? One of the parts of our residual analysis, we calculate the residuals, we get the mean of the residuals, and then we make a scatter plot of the residuals. So the whole idea here is if your scatter plot of residuals is random with no pattern, that indicates that the line is a good model. So again, this just kind of supports, what we've hopefully already found out when we ran our test. And like I said, we're kind of using this in place of a confidence interval. So it's just one more thing to kind of confirm our findings. And we haven't really talked about it yet, but here's my t-test, and I have a p-value of 0.01. Well, knowing what we know about p-values, if it's less than alpha, we reject the null. And in this case, when we reject the null, that means it is a good model. So this supports that fact that it's a good model. So again, I've got some typos because I just copied and pasted these questions. Does a linear model seem to be appropriate for describing the relation between high school GPA and math SAT? So the answer is yes. Can't write today because the mean is approximately 0 and the scatter plot has no pattern. Now, when I say it has no pattern, I want you to be aware that, some of them, they will have a definite pattern to them. And by pattern, I mean they form a straight line, or they look like a parabola, you will be able to tell when it has a pattern. Okay, this looks like I just dropped some confetti on a piece of paper. There is no distinguishable pattern. It's random. That's that. So that tells us that it is a good fit. Okay, because again, this is our residuals. So this is how far above or below the predicted values we are. So you can kind of assume that this axis is our predicted values. Residuals we're showing above or below. So we should have a good mix of both, and it should be random. So now just some further questions to think about residuals. What does it mean when a residual is positive? So we kind of saw this on the front page. And we talked about this. So when a residual is positive, that means they scored higher than predicted. Okay. Number 2, true or false. If the correlation coefficient, and remember correlation coefficient is your R, is negative, then the slope of the linear regression equation must also be negative. So if you remember from correlation coefficient, if it's negative, that means there's this negative relationship going downhill. Well, then it should make sense that once you put the regression equation in here, it must also have a slope that's negative. So this one is true. And then explain what is wrong with this statement. We have concluded that there is a high correlation between male drivers and rates of automobile accidents. Any thoughts before I say what's wrong with it? The error here is high correlation. We don't talk about correlation that way. We talk about correlation in terms of strength and direction. So to say high correlation, we would not want to do that. We would want to give some sort of indication of direction and strength.
Mommy. Yeah.
I'm assuming it would be something like a strong, hold on. I'm assuming it would be something like a strong positive correlation. Okay. So that's some correlation, or I'm sorry, I can't even think with these kids. That's a residual analysis. So the next video that I make, we are going to actually start going through some full examples. So I'm going to do a couple of examples, couple full examples, and then you'll be able to do the last homework.